Hello everyone, welcome to the video. Today's topic is the OSI model, Open Systems Interconnection model. In this video, we will learn complete information about how the OSI model works and why it's important in networking. Let's get started. The OSI, Open Systems Interconnection model is a conceptual framework that describes how network devices communicate. It provides a standardized way to understand and visualize the complex process of data transmission across a network. The model is structured into 7 distinct layers, each responsible for a specific set of functions. This layered approach simplifies network design, implementation, troubleshooting, and understanding. It promotes modularity and interoperability, allowing different network technologies to work together seamlessly. 1. Physical layer. Layer 1, the foundation. The physical layer is the lowest layer of the OSI model. It deals with the raw, physical transmission of data, bits, over a physical medium. This layer defines the electrical, mechanical, procedural, and functional specifications for activating, maintaining, and deactivating the physical link between network devices. It's concerned with physical characteristics of interfaces and media. This includes specifications for cables, connectors, voltage levels, signal timing, and data rates. Examples: types of cables, copper, fiber optic, wireless frequencies, connector pinouts. Representation of bits. How bits are represented as electrical or optical signals. Examples: voltage levels for 0 and 1. Modulation techniques. Data rate, the speed at which data can be transmitted over the medium. Examples: 10 megabits per second, 1 gigabit per second, 10 gigabits per second. Synchronization of bits, ensuring that the sender and receiver are synchronized in their transmission and reception of bits. Line configuration, how devices are connected, point-to-point, multi-point. Physical topology, the arrangement of devices and connections. Examples: bus, star, ring, mesh. Transmission mode, the direction of data flow. Examples: simplex, one-way, half duplex, two-way alternating, full duplex, two-way simultaneous. 2. Data link layer, layer to reliable link. The data link layer builds upon the physical layer and is responsible for reliable data transfer between two directly connected nodes. It takes the raw bits from the physical layer and organizes them into frames, adding header and trailer information. Key functions include framing, dividing the bit stream into meaningful units called frames. Addressing, MAC addressing using media access control. MAC, addresses to identify devices on the same network segment. MAC addresses are unique hardware identifiers. Error detection and control, detecting and potentially correcting errors that may occur during transmission. This often involves checksums or other error detection codes. Flow control, managing the rate of data transmission to prevent a fast sender from overwhelming a slower receiver. Access control, in some cases, regulating access to the transmission medium to prevent collisions, example, in shared Ethernet networks. 3. Network layer, layer 3 routing and logical addressing. The network layer is responsible for routing data packets across networks. It enables communication between devices on different networks. Its primary functions are logical addressing, IP addressing, assigning logical addresses, IP addresses to devices. IP addresses are used to identify devices across different networks. Routing, determining the best path for data packets to travel from source to destination. Routers operate at this layer. Fragmentation and reassembly, breaking down large packets into smaller fragments for transmission across networks with size limitations and then reassembling them at the destination. 4. Transport layer, layer 4 end-to-end connection. The transport layer ensures reliable end-to-end delivery of data between applications running on different hosts. It provides services to the application layer. Key functions include segmentation and reassembly, breaking down data from the application layer into smaller units, segments, for transmission and reassembling them at the destination. Connection-oriented versus connectionless service. Providing either a connection-oriented service, like TCP, which establishes a connection before transmitting data and guarantees delivery, or a connectionless service, like UDP, which sends data without establishing a connection and does not guarantee delivery. Flow control, managing the flow of data between applications to prevent congestion. Error control, detecting and correcting errors that may occur during transmission. 5. Session layer, Layer 5. The session layer is responsible for establishing, managing, and terminating sessions between applications. It handles the dialogue between applications. Its functions include session establishment and termination, initiating and closing communication sessions between applications. Session management, controlling the flow of data during a session. Synchronization, adding checkpoints to long transmissions to allow for resumption in case of failure. 6. Presentation layer, Layer 6. The presentation layer is concerned with the format and representation of data. It ensures that data is presented in a way that applications can understand regardless of the underlying system. Its functions include translation, converting data between different formats, example, character sets. Encryption and decryption, encrypting data for secure transmission and decrypting it at the receiver's end. Compression and decompression, compressing data to reduce the amount of data transmitted and decompressing it at the destination. 7. Application layer, Layer 7. The application layer is the topmost layer of the OSI model. It provides network services directly to applications. This is the layer that users interact with. It includes Network Virtual Terminal, allows a user to log in to a remote host. File transfer, access, and management, FTAM enables users to transfer files between systems. Mail services, provides email services. Directory services, provides directory services for locating resources on the network. Web browsing, HTTP enables users to access web pages. Why is the OSI model important? The OSI model is crucial because it simplifies troubleshooting by breaking down network communication into manageable layers. It promotes standardization and interoperability, enabling different devices and technologies to work seamlessly together. Additionally, it enhances network design and scalability, allowing for easier upgrades, maintenance, and expansion. By understanding the functions of each layer, network professionals can diagnose issues faster and design more efficient, reliable networks. That brings us to the end of this video. I hope you now have a clear understanding of the OSI model and its working process. If you found this video helpful, make sure to like, share, and subscribe for more informative content. Thank you for watching, and I'll see you in the next video.